Hello and welcome to my presentation. My name is Peter Lorenz and I'm going to present you our work with the title Detecting AutoAttack Perturbations in the Frequency Domain. So, what is it about? The applicability of neural networks is limited by its vulnerability against adversarial attacks. Attack methods, for example, AutoAttack, which has a very high success rate. Consequently, defense methods appear one step behind. Therefore, we propose a Fourier-based approach to detect adversarial examples where features are extracted in a frequency domain. We investigate a black box and a white box detector. The black box detector calculates the Fourier spectrum of the input image. The white box detector calculates the Fourier spectrum of the feature maps. We also introduce a new measurement. First, the adversarial attack rate, short ASR, is calculated by the numbers of perturbed samples divided by all samples. Second, the adversarial attack rate under detection, short ASRD, is calculated by the number of undetected perturbations divided by all samples. This is equal to the false negative rate of the classifier times the ASR. For datasets, we use the simple Cipher 10 and the more complex ImageNet. We attack the images with different epsilons. From the AutoAttack, for example, 8 divided 255 is usually a good choice by default. The detection rate is very high. The ASRD is 0. We can see that the ASR falls by smaller epsilons. On the ImageNet, we get good detection results. Note that the ASR does not fall heavily on the ImageNet. Logistic regression classifier is used to obtain the white box results on the ImageNet. The rest of the results is determined by the random forest classifier. Conclusion. The conclusion is that we detect instead of hardening. Frequency features are able to detect state-of-the-art attacks. The black box approach could provide a countermeasure for real applications. We have still many open questions. So, the first is, how does the detectors perform on other datasets, network architecture, and attacks? The second, why is AutoAttack so successful for very small epsilons on ImageNet? The third, can the detection be combined with adversarial training methods? Published on the Robust Bench website.